Hello people, welcome to Gurukula. I am Jai. So today in this video we are going to start our second module of communication networks. In the second module we are going to cover all the concepts that is related to media access control layer and then few concepts about the internetworking threads. So now without wasting any further time, let's get into the topic. So just to summarize what we are going to study in this particular course, communication networks. So I have already displayed this particular course module in the very first introduction slides as well. So we have now completed the fundamentals of networking. So we have successfully completed all the concepts that is involved in fundamentals of networks. So today we are marching into the second module, that is media access and then internetworking. So in this module we are going to see the few topics that are listed under media access and then internetworking courses. So for the next few days we are going to see the topics that is listed under the second module over here. So now let us see what are all the things that we have already discussed in the data link layer in the first module. So we very well know that the data link layer is not in one single layer. It is further classified into two sublayers. So two sublayers are, the first one is LLC, which is logical link control, which acts as an interface between media access control sublayer and then the network layer. And then the second sublayer is MAC layer, that is media access control layer, which is actually responsible for moving the data packets from one NIC card to another NIC card. And then we have seen the various functions of the data link layer, out of which we have discussed the physical addressing, framing, flow control, error control and access control. And we have also seen that the first two is function of media access control sublayer and the rest of the functions are the responsibility of logical link control sublayer. And then we might have already discussed about the physical addressing and then the error control in detail in our previous classes itself, whereas in our first module we have covered all these topics in detail. So today in this particular course we will throw some light on the framing, the remaining portions which we wanted to cover. Fine. So in module 2, this is what going to be our agenda of the courses which you are going to follow. So first of all, today in this particular module we are going to talk about framing, and we will take all these topics which is involved in framing. And then in our subsequent videos we will talk about flow control, access control and then the rest of the topics that is related to the second module. So now first of all, in order to understand what exactly framing is, let me take an example of sending some data to my friend. So say for an example, I wanted to send few messages to my friend by using a postcard. So in postcard I will have different fields to fill my data, right? So what I will do is I will just generate a data and then put it in a corresponding area where it is intended to be. But it is important to remember that only the data is not sufficient to take the postcard to the intended destination. So we need some more additional informations to be added on this postcard so as to make a successful delivery to the right destination. So what I will have to do is I will have to mention the address of the recipient in the place intended for it. So now I have written the second chunk of data. This is what the first chunk of data, which is actually my message, and this is the second chunk of data which is actually representing where I am posting this particular card, which means the recipient's address. And then in addition to that we need a third chunk of data which actually represents from whom the message have been actually generated. In technical jargon we call that as source address. And then in all top of it we will also have another bits of information that is actually representing the value for this particular postcard. We will have to affix a stamp according to the value to where it is getting posted over it. So it is very much understood that the only data is not enough for us to communicate the message from one point to another point. We also have several amount of data like sending address, receiving address, and as well as other relevant informations which will tell you to get any relevant informations. So when I put all these things, I need a data, I need a source address, and I need a destination address, and finally I need a stamp value. All these data are embossed in this particular postcard. Only now this postcard can able to be rightly delivered to the right person. So arranging all these necessary informations in a particular format is what we call it as the process of framing. See, when I can combine that, the source address and destination address can be combined together, and then it can be called as a header field, and then we have some actual data which has to be transmitted, that is what we call it as the data field, and then any stamp value or any redundant information which is used for any purposes, we call it as the trailer. So that we are adding some information in front of data bits, and then we are adding some information at the back of the data bits. So this process of adding the header and then the trailer field is what we call it as framing. So this is an actual example or a typical example of how does a frame will look like. Say for an example, the header may have the identification of start of the frame, it may have the addressing information such as source address and then the destination address, and it can also have some bits to represent what type of frame is that, and also there are few bits that actually takes the quality control. Then you will have the actual data which you wanted to transmit, and then in the trailer part you can see that the codes that are responsible for error detection, and also few sets of codes that is responsible for detecting the end of the frame. So all these informations are arranged in a prescribed format, and this is what we call it as framing. So now you might have understood what exactly the framing is, and with this knowledge we can see some actual frame formats of Ethernet and as well as the wireless LAN. So this is how a frame format of Ethernet will look like. So whenever I am communicating a messages from one node to another node which is connected using an Ethernet protocol, then this could be the frame format which we can see. And this frame format is also very much similar. Here we have the data field, and before to this data field we have header, and then after to this data we have trailer as studied in the frame format. And similarly, when I throw you the frame format of wireless LAN, similarly you can see that the frame format is really getting complicated since it is wireless, and even here you can see that the frame body is actually representing the data, and then there are few informations represented before the data, that is what we call it as header, and then there are few informations that is represented after the data, we call it as trailer. So the main thing which we wanted to keep in mind over here is the frame will be varying depending upon the protocol that we use to communicate the message from one node to another node, be it an Ethernet protocol or be it any wireless protocol. Each and every protocol will have their own frame format to be communicated, and this frame format must be agreed by both sender and then the receiver before the start of the transmission of the frame. So now there are two types of framings available in the network. So what are all the two types of framing? So we have fixed length framing, and then in fixed length framing we will have the header, we will have the data, and then we will have the trailer. And as far as fixed length framing is concerned, you can clearly notice that the size of the header, the size of the data, and the size of the trailer is already fixed, which means you can put only 10 bits of information in the header, and you can put only 20 bits of information in the data, and you can put only 10 bits of information in the trailer, so that the total frame size is 20 plus 10 is 30, and 30 plus 10 is 40. So the total frame size will be 40 bits. So we cannot extend or shrink the size of the frame. The frame size is already fixed. So this type of frame is what we call it as fixed length framing. And whereas on the other side you have another framing, that is what we call it as variable length framing. And whereas in variable length framing, similarly you will have header, data, and then the trailer, but the difference is the field that is available for data, the number of bits, it can be variable. So if you have less amount of data, you can use the less amount of data, and then if you have more amount of data to be transmitted, you can increase the size of the data field as and when it is required. But the size of the header and then the size of the trailer is always fixed, because we are going to carry only predefined informations on these particular fields. Likewise, your header is going to carry the source address and then the destination address and something like that, and your trailer is going to carry few bits that is responsible for error detection, error correction codes. So all these bits are already fixed. So there is no point of giving a variable frame for this particular sections. So header and trailer is going to have a predefined amount of length, and only the data field is variable. So this kind of frame is what we call it as variable length framing. So now coming to the advantages and disadvantages of these particular frames, we can clearly see that the fixed length framing is very much suitable for when I am going to transmit only small amount of data. So when I am going to transmit a small amount of data, it is really a small frame is enough for me to send a data from one point to another point. And when it comes to variable length framing, it is very suitable, or it is very efficient when I have large amount of data to be transmitted from one point to another point, or from one node to another node. Now let's take for an example, if I have 100 bits of data to transmit. So how many frames will be transmitted in fixed length framing? So if I have 100 bits of data to be transmitted, and here you can see I can incorporate only 20 bits at a time. So I should need 20 into 5, which gives us 100. So I need 5 number of frames that is required. So I need 5 frames to be transmitted in case of fixed length framing. So in order to transmit 100 bits of data. But whereas in variable length framing with the same 100 bits of data, what I can do is I can extend the maximum size of the data to 100 bits, and then I can send all the data only in just one frame itself. So the number of frames that is being transmitted over here in fixed length framing and variable length framing can be viewed with this particular example. So now the actual problems comes into the picture. Now say for an example, a sending node is node A and then the receiving node is node B. Now if I want to send a frame from node A to node B, then node B should able to identify where exactly the frame is getting started and where exactly the frame is getting ended. And as you all know that the two systems will communicate as a series of ones and zeros. So all the data whatever we add in frame is nothing but that is series of ones and zeros. Now how does the node B will identify that the frame has started, and then where will it identify that the frame has got ended? So identifying the start of the frame and then the end of the frame, or in other words we can call that as boundaries of the frame. How is it being identified at node B? So that would be the question which could arise in your mind. So that this boundaries of the frame, identifying the boundaries of the frame is not a serious task as far as fixed length framing is concerned, because in fixed length framing we very well know that the size of the frame is only 40 bits as far as this example is concerned. So I will take the first bit as the start of the frame, and then I will keep on counting the bits, and when I get 40th bit I will assume that the frame has ended. So identifying the start of the frame and then the end of the frame is not a big task whereas fixed length framing is concerned. But unfortunately most of the real-time applications on internet will follow variable length framing. As such we can send more amount of data in one single frame. So in variable length framing we do not know the length of this particular data field, so that we could not able to identify where exactly the frame is getting started and where exactly the frame is getting ended. So identifying the boundaries of the frame becomes really a challenging task, whereas it coming for variable length framing. So how do I identify the boundaries of the frame, especially in variable length framing? That would be the question which we will be addressing in the subsequent slides. So identifying the boundaries of the frame can be done in two ways. One is byte oriented framing and another one is bit oriented framing. So now we will see the difference between these two approaches one by one. So whereas in byte oriented framing, what I will do is normally the frame from the upper layer comes with the header and then the trailer information. We very well know that. And also we also know header information contains source and destination addresses, and trailer will contain error detection and then the correction information. So now the frame will look like this. We very well know that. So we have a data that is received from the upper layer, which is an variable length framing, whereas we don't know the length of this particular data field. And then in addition to the data, we will have header information and then we will have trailer information. All these informations are already known to us. Now the question that we are addressing is, how do I address the boundaries of the frame? So in order to address the boundaries of the frame, an 8-bit flag is being added at both the ends of the frame like this. There you can see there is an 8-bit flag that is appended before the header and after the trailer. So whenever the receiver, as in our example, a node B, that is what we calling it as receiver, and then a node A, we call it as a sender. So whenever a frame is being sent from system node A to node B, a system node B will receive the flag bit first. When the flag bit is received, the system B will identify that the frame have been started, and then it will keep on processing the frame. And then whenever a second flag bit is received, the frame B will assume that the frame have been ended, and this flag is nothing but an 8-bit of information. Let us, for an example concern, I will take it as 4 pairs of ones and zeros. So this 4 pairs of ones and zeros, whenever it is received for the first time, my system B will identify that this is the start of the frame, and then it will keep on processing the data. And also whenever I receive another 4 pairs of ones and 0, I will assume that this is the end of the frame. So that is how the boundaries of the frame is being identified by using byte oriented approach. So now what could be the problem over here in this byte oriented approach? Yes, exactly. The flag may contain the special characters that we already know. But now the problem with the flag is, this method is generally suited for text transmission. So but in case of audio and then video, the transmission of this particular flag may appear as a part of the data. So how is it being identified over there? So if the pattern is as same as the flag, then the receiver may misinterpret that it is the end of the frame. So this problem can be identified by adding an additional byte of information. That is what byte stuffing is. So the problem deals with, let's take for an example, this is the frame which I wanted to communicate, and then this is what the flag which I have added. So as far as our example, we have 4 pairs of ones and zeros to represent the boundaries of the frame. So now we have quite a lots of possibilities that this similar flag may appear as a part of the data as well, so that the receiving system may misinterpret that this is the start of the frame and this is the end of the frame. This may happen when we transmit flags as such. So in order to overcome this particular drawback, we are adding another byte of data. That process is what we call it as byte stuffing. So in this method, an extra byte is added to the data section, and that particular byte which is added is what we call it as escape sequence. Now we will see how escape sequence comes into the picture. This is how we can stuff an additional byte of information just to come out of the problem that we have discussed in the previous section. So whenever I encounter a flag sequence in my data, what I will have to do is I will have to add an additional byte of information, which is what we call it as escape sequence. This escape sequence is again nothing but it is another 8-bit of data. Now what I will do is, let us consider that this is my escape sequence, and we very well know that our flag is 10 10 10 and 10. This is what our flag is, and then I will consider this as my escape sequence. Fine. So now what I will do is, whenever I have a flag sequence appearing in my data, I will stuff an additional byte of information, that is what I call it as escape sequence, inside the frame. and then the same problem that appeared for the flag may also appear to escape sequence. We may not assure that the escape sequence will not appear anywhere in the data. So what we should do in those cases? There is a possibility of appearance of escape sequence in the data sequence as well. So in those cases, we will have to add additionally an escape sequence next to the escape sequence also. So that the byte stuffed frame, and this is what we call it as byte stuffed frame, and in this frame will have two consecutive escape sequences. Now it will be easy for the receiver to identify whether this is a start of the frame or this is a part of the data. So whenever I receive only the flag sequence not followed by any escape sequence, then it will be assumed as the start of the frame, and then it will keep on processing, and then it encounters an escape sequence, and then you could observe that there are two escape sequences appearing simultaneously or consecutively. Fine. In this cases, only one escape sequence will be removed, and then the next escape sequence will be kept as such, assuming that this is a part of the data, and then it will further keep on processing, and then whenever a flag is encountered, it is also observed that there is an escape sequence next to it, so that this escape sequence will be eliminated there at the receiver side, and then the flag sequence will not be disturbed, assuming that this is the part of the data. So that there at the unstuff, after unstuffing the escape sequences, we can end up with the same messages whatever been transmitted. So this is what the transmitted frame, and this is what the received frame over here, and you can observe that the received frame is as similar to the transmitted frame. So this is how the problem of misinterpreting the end of the frame is being overcome by using the byte oriented framing method. So now again, there are some drawbacks in this byte oriented framing, which means, say for an example, here in our example there are two occurrences. Let us take the frequency of occurrence of the flag and escape is 2. So if there are two occurrences, then I will have to add 2 bytes of information to overcome this. So 2 bytes of information is nothing but it is 16 bits of data, which is actually an redundant bit, which doesn't have any useful information over here in the frame. So just in order to overcome 2 occurrences in my frame, I am adding 16 bits of redundant information which is unnecessarily sent, which is consuming quite a lots of transmission power and then the bandwidth resources. So in order to overcome this particular drawback, we are moving forward to another approach, and that is what we call it as bit oriented framing approach. So what's special in bit oriented approach frame? So here in bit oriented approach, we will use the flag sequence as 8-bit sequence again, but this time we are going to have the flag sequence is going to start with a 0, and then it will have 6 consecutive ones and then followed by a 0, and then this flag sequence will be used for identifying the boundaries of the frame. So in our previous example, I said it is 4 pairs of ones and zeros, or it may be anything that is decided by the protocol. But here in bit oriented framing, what we will do is we will take 0 and then followed by 6 consecutive ones and then again followed by a 0. So this represents the start of the frame and then the end of the frame. Now again, the same problem may appear. There may be some possibilities that this flag sequence appears in the data sequence also. So that what I should ensure is, in flag I have 6 consecutive ones. So the only thing which I wanted to ensure is, in data sequence I should ensure that there should not be any 6 ones appearing consecutively. So that what I will do is, whenever I encounter 5 consecutive ones, I will add 1 bit, or I will stuff 1 bit to break the sequence, so that I am ensuring that the 6 ones is not appearing anywhere in the data over there, so that whatever the number of occurrences is equal to the number of bits that I am going to stuff. So that the trade-off between the redundancy bit and then the data bit that is being carried on the network will be efficient. So this strategy is what we call it as bit stuffing. Now let us try to understand bit stuffing with an example frame. See, this is an example. So here the frame will be processed in this particular direction, and then the main factor, and it is very much important to remember that the flag sequence that is representing the start and end of the frame is starting with 0 followed by 6 consecutive ones and then followed by a 0. So now my only task is I should ensure that in data field there should not be 6 consecutive ones appearing anywhere. So what I will have to do, if I encounter 5 consecutive ones, I will stuff a 0 bit inside it without any consideration of the next bit. So irrespective of the next bit, I will stuff a 0 bit between a particular one value whenever I encounter 5 consecutive ones. So here what we can say is it will process in this particular direction. So here 1, 2, 3, 4, 5 consecutive ones have been detected, and then irrespective of the next bit I will stuff a 0 over here, and this 0 is what stuffed over here, and then further I will start processing the next informations. So again I can see that there are 5 consecutive ones, 1, 2, 3, 4 and 5. Again 5 consecutive ones are identified, so I will stuff another bit over here. By making this, I am ensuring that the data field does not have 6 consecutive ones anywhere in the appearance of the sequence, so that my flag sequence is not going to appear anywhere in the frame, so that the system B will happily identify the start of the frame and then the end of the frame over here and here. So this approach is what we call it as bit stuffing approach. So that's the end of the session. So today in this particular session we might have seen what exactly the framing is. So it is a process of adding redundant information such as header and then trailer to the data units received from the upper layer. And then we have seen the types of framing. We have seen 2 types of framing. The first one is fixed length framing. As far as fixed length framing, it is very easy to process because we don't have any challenges in identifying the boundaries of the frame, and then but the sad part is it is not suitable for the larger data transmission. On the other hand, we have the variable length framing, which is very much efficient for transmitting larger data, but the challenging task is it is very difficult for us to identify the boundaries of the frame, which means the start and end of the frame has to be identified by the receiver. So in order to overcome this challenge, we have seen there are several methods. We have seen there are 2 types of methods. First one is byte stuffing method. In byte stuffing method, a flag is being added to identify the start and end of the frame. And then we encountered a problem that there is a possibility of occurrence of the flag itself in the data. So that in order to overcome this problem, we have introduced an additional or an addition of escape sequence in it. So whenever there is an occurrence of flag sequence or escape sequence in the data unit, then an additional escape sequence has to be added next to it. So this is what the byte stuffing is. But the overall drawback of the byte stuffing is in order to overcome just 2 or 3 appearances of flag and escape sequence, there is a huge amount of bits that is we are going to add as a redundancy bit, which will definitely overburden the bandwidth requirements. So in order to overcome this problem, we go for another approach, that is what we call it as bit stuffing or bit oriented approach, whereas here flags are kept constant and then only 1 bit is stuffed if 5 consecutive ones are encountered. So by doing this, we are making sure that the flag sequence is not appearing anywhere in the data unit. And also the number of bits that we are adding as a redundancy bit is also greatly reduced as and when compared to the byte stuffing method. So these are all the various topics that we have seen in this particular video, and then I am going to see you in the next video. Until then, it's bye from Jai, and then happy learning.